Hello everyone. In this section we will discuss about the multi-layer perceptron. Here is a table of content. We will discuss what is multi-layer perceptron. After that we will discuss the working of multi-layer perceptron, and in the end we will discuss the implementation of multi-layer perceptron. First we will discuss what is multi-layer perceptron. Basically, multi-layer perceptron is a class of feed-forward artificial neural networks. In the multi-layer perceptron, there can be more than one layer, or you can say a combination of neurons. For example, if we take the 3-layer networks, the first layer will be the input layer, and the last layer will be the output layer, and the middle layer will be the hidden layer. We can also increase the number of the hidden layers as much as we want to make the model complex based on the task. So basically, multi-layer perceptron defines the most complex architecture of artificial neural networks, and it is formed from multi-layers of the perceptron. We will discuss the working of multi-layer perceptron. So there consist only 3 layers. The first one is input layer, the second one is hidden layer, and the last one is output layer. The input layer defines that we will take a inputs, and there is only one input layer and it accepts only different formats. And hidden layer defines the layers are between the input and output layers, and it executes all the calculation to find the features, and it will calculate the output based on the weights, that will be W1, W2 and so on to Wm. And there can be one or more hidden layers that take place in the inner layers. These are the inner layers. To create a neural network, we join neurons together so that the result of some neurons are inputs of other neurons. And every node in the multi-layer perceptron applies a sigmoid activation function. And this function takes values as inputs, and it will be considered as 0 and 1 using the sigmoid formula. Multiple layer perceptron is used for solving problems that need to be supervised learning as well as research, and it also used for making an application like image recognition and machine translation. So basically this diagram is based on the multiple layer perceptron, and we can use the sigmoid activation function in it, and it displays the S-shaped graph, and the range value will be start from 0 to 1. Now we will see the implementation of multi-layer perceptron. In this example, first we have imported all the necessary libraries, and then after that we have downloaded the data set. So TensorFlow allows us to read the MNIST data set, and we can load it directly in the example as a train and test data set. After downloading the data set, now we will convert the pixels into floating point values. So we are converting the pixel values into floating point values to make the predictions, changing the numbers into grayscale values. So grayscale values has been represented as scale underscore value. So it will be beneficial as values. So as a pixel values, the range values start from 0 to 256. Apart from 0, the range is 255. So dividing all the values by 255, we will convert into the range from 0 to 1. Now we will understand the structure of the data. After executing this code, it displays the 60,000 records in the training data set and 10,000 records in the test data set, and every image in the data set is size of 28,28. Now we will visualize the data. For this I am going to create two variables, that is fig and new value, and set the axis, that is 5,5, and iterate the loop by using for loop method, and set the value in it 5, 5. After visualizing the data, now we will discuss the input, hidden and output layers. Basically the sequential model, in this we have used the sequential model. This allows us to create models layer by layer as we need in a multi-layer perceptron, and it is limited to single input and single output stack of layers. Flatten defines the input provided without affecting the batch size. For example, if inputs are shaped like batch size without a feature axis, then flattening adds an extra channel dimension and output shape will be batch size, 1. In this we have assign the activation function, that is sigmoid, and then we have defined first two denser layers, and it is fully connected model, and that represents the hidden layer. The last dense layer is the output layer, which contains 10 neurons that decide which category the image belongs to. Now we will compile a model by using model.compile. Compile function is basically used here, that involves the use of loss optimizer and the matrices. Here loss function is used is sparse categorical cross entropy, and the optimizer used is Adam. Now we will fit the model by using model.fit. In this we have assigned the value approach, that is 10, batch size 2000, validation split 0.2. So basically approach tell us the number of times the model will be trained in forwarding and backward passes, as well as batch size represents the number of samples if it is specified. By default the value will be 32, but in this example I have set the value, that is 2000. And the validation value is always represented as the floating value, and the values will be defined into a 0 to 1. The model will set apart this fraction of the training data to evaluate the loss and any model matrices at the end of each approach. So as you can see that after executing this, the approach value will be 10. So now we will find the accuracy of the model. So after executing this code, we got the accuracy of our model, that is 92%, by using model.evaluate on the basis of test samples. With this we have completed the multi-layer perceptron.